A Global Positioning System navigation device, commonly known as GPS, is a device that is capable of receiving information from GPS satellites to accurately determine current geographical location. GPS navigation is the most convenient and universal way to navigate, whether it's a driver traveling to an unknown location or a tourist searching for attractions. We rely 100% on those devices. Nowadays, most standalone GPS receivers are used in vehicles. On the other hand, modern smartphones use assisted GPS or AGPS technology that utilizes base stations or cell towers to ensure location tracking capabilities when the satellite signal is lost. But even AGPS technology won't help when the smartphone is outside of the mobile network or when a vehicle with installed standalone GPS receiver drives into a building, garage, or tunnel and the signal is lost. Everybody got used to GPS navigation so much that when such a situation happens, drivers feel very uncomfortable. While working on solving the problem, OCSICO team has developed an alternative solution called Indoor Positioning System, which does not require GPS for navigation. The system went from an easy Bluetooth-based to a more complex Wi-Fi solution and later to even more sophisticated magnetic fields-based system. Each solution's version serves the purpose but has different areas of applicability and various levels of maintainability. Bluetooth-based application, created for use in such areas as multi-level parking lots, was the first developed solution. The way it works is the following. Special Bluetooth beacons are placed around the area. Since the beacons are geographically fixed and each has an identifier, they can be used for navigation based on unique IDs and locations on the map. When approaching a multi-level parking lot, a user scans a barcode and downloads a mobile application with built-in map of the building. The application further works as a regular GPS device, allowing navigation around the area. For example, the app records location of the parked car and provides guidance to the nearest exit or other places of interest. The user's location is defined with the help of beacons and the current position is displayed precisely on the map. The solution was easy to use and reliable, but due to beacons' low signal range, a great amount of them was needed to cover large spaces. Moreover, additional efforts were required for installation and maintenance of the beacon network. Further, the solution evolved into a Wi-Fi-based application that could be used in large areas such as shopping malls. Wi-Fi technology is expanding nowadays. That's why it's possible to find several Wi-Fi hotspots in every retail store. Wi-Fi signals can be set up for different purposes: wireless payment terminals, IP cameras, internet routers, and so on. Obviously, very few of them allow for an unauthorized user to connect and register. Even more, most of them are invisible for standard discovery by a mobile device. The main idea behind this solution was that we do not need to establish an actual connection. All that was required for the solution's functionality was a device location, unique name, and signal strength. Based on this information and standard buildings map, our engineers could create a signal-based map of the area. Advanced proprietary algorithms allow transformation of gathered information into a ready-to-be-used navigation map. Since Wi-Fi hotspots could be moved around, removed or switched off at any time, continuous maintenance of Wi-Fi map is required. That's why we started thinking about a more sophisticated and cost-effective solution. One of the possible solutions that we considered was the use of a magnetic fields positioning. The idea behind the solution is based on the fact that all areas on Earth have different magnetic fields. Therefore, this information could be used for navigational purposes. The main advantage of this approach is that no additional infrastructure or costly installations are required. Moreover, the magnetic field signals are usually quite stable, hence there is no need for continuous maintenance. Still, it's an experimental study yet because the algorithms for calculation of current position are much more complex compared to algorithms used in Wi-Fi or Bluetooth solutions. That's because calculation is based not on absolute signal value, but on the dynamics of the magnetic field's fluctuations within a fixed time frame. Besides, those dynamic changes could be similar in different spots, which means that even more complex approach to algorithms is required. Moreover, the sensors of modern devices are not sensitive and efficient enough to calculate current position in real time. That's why most of the work is done offline, such as calculations of gathered data on the server. We're currently continuing the development with the help of leading scientists of the Republic of Belarus, with the ultimate goal to make the magnetic fields-based solution perform real-time calculations. Cell phone makers are currently performing a lot of research on the subject as well, and hopefully a brand new technology with a simple yet elegant solution to this challenge will soon appear.